All and very warm welcome to the session. Yes, everyone, so happy to see you all back in this session. Yes, Pooja, we are here. Yes, little. Okay, so nice, everyone. Okay, so there was a little bit technical glitch, so I was not able to connect. I think now I am visible, I am audible, and yes, everybody, fantastic. So that's great. So let us begin our session for the day. Okay, right. So today we are going to learn about Ramachandran plot. Yes, so a Ramachandran plot as such, it is a very important topic for your revision because seriously it is a worthwhile topic to study. So far we have been reading with important subtopic from every unit. Okay, so as far as this biochemistry is considered, absolutely Ramachandran plot serves as a very important point. Yes, Priti, so this is associated something with your protein structure. Okay, so this speaks more about the protein structure, especially it is going to elucidate the 3D structure of the protein. Okay, it is going to tell, yes, net aspirants, yes, Pankaj, so it is going to tell seriously, yes, good evening everyone, yes, creation overload, nice. So it is going to tell us the total 3D structure and all, so it gives us an immense idea about the structure with reference to the positioning of the dihedral angles. Yes, Archie Sarma, so it tells about the dihedral angles. So we will be seeing, anything will have an angle. So if you take a square also, it is going to contain an angle. Likewise, our proteins, it is made up of your peptide bond. It is going to contain so many angles. So that angle is what is elucidated to understand the different dimension of the structures, whether it is going to be an alpha helix or a beta sheet. So this is what Raman's plot is all about, right? Okay, yes everybody, good evening, good evening. So this is little bit about myself. Yes, if at all you are new to me, I am Dr. Saranya. I have cracked my CSIR NET and I have completed my Ph.D. in Biomaterials. Okay, so I am teaching you to help you to crack your examination. Got it? Right. Fine. So this is a little bit advantage of iconic subscription over the plus subscription. Yes, Elva. Yes, Suman. Seeing you after a long time. Okay. So as far as this plus classes are considered, you will meet in the live class. You will be participating in the weekly test. Absolutely. If you don't understand something, you can rehear. Yes, Elva. So you can have a visit at the structured courses. This is what you get in a plus class. In case of iconic, you will have personal guidance, test analysis, experts and the plan. Alright, fine. So now, this is the information about the subscription. If at all you have not yet subscribed, high time that you can come up with a subscription because your exams are very close. Whatever, yes Anita, whatever you are going to learn in the last 60 plus days, it is what is going to decide the examination fate, right? So seriously, I want everybody to crack the examination. For that you have to an intense preparation. Come on, prepare with me. Take up a plus or iconic subscription such that you can make a big difference in your preparation. Yes? Alright. So stay connected. Chat with me in the Telegram channel as well and participate in the live special classes. You can download the notes. Yes. Alright. So coming back to our today's topic, Ramachandran plot. What is this structure about? Yes, everybody. What is this structure all about? This is a typical structure of an amino acid, isn't it? Right. So if at all I am going to take up an amino acid, this amino acid is going to contain a carboxylic group. Okay. Carboxylic group. So this, because of this carboxylic group only, you call them as an acid, right? It is going to contain an amino group, correct? So then that is why it got the name amino acid, okay? So to it you have a C alpha carbon. What do you mean by C alpha carbon? The C alpha carbon is the carbon that is being connected with your R chain as well as it is connected with your amino group, right? So this amino group is connected, it is called as an alpha amino acid. Okay, right. So here, yes, R is going to be H. So this is the structure of glycine. Okay, so if at all I am replacing this by different structures, absolutely it is going to represent the different amino acid. Now, what are the kind of angles that is possible? You can have a C alpha and C, correct no? If there are 4 molecules, imagine this is one molecule, this is the second, this is the third, this is the fourth. So this can form an angle, correct or not? Yes, these two can form an angle, right? These two can form an angle, these two can form an angle, yes or no? That is what is called as the dihedral angle. So what it is called as? It is called as dihedral angle. So it has another name called as the torsion angles. So what are the other names? Torsion angles. So you have two angles. One it is going to be the dihedral angle. Other one it is called as the torsion angle. So what are the torsion angles and dihedral angles? Majorly 4 angles are there. 3 are very much explored and 1 is little bit less explored. Yes, absolutely. So what are they? Number 1, it is called as chi angle. Okay, chi angle. Number 2, it is called as psi angle. What is that? Psi angle. Number 3, it is called as omega. Okay, right? Number 4, it is going to be chi angle. Okay, fine. So these are the different angles: psi, omega, and then chi. Okay, so these are the 4 angles that are present. So this C alpha and C, yes, C alpha and C both are same. No, it is boring. Psi it is. Okay, so it is the psi angle. C alpha and N, it is very interesting now. So it is spicy, psi angle. And then omega, it is the angle between C and N. Can you see that? It is the angle between C and N. That is omega. It is very, very rigid. It looks like a partial double bond. How it looks like? It looks like a partial double bond. C and N, it is a partial double bond. And this angle, yeah, this angle C alpha R, it is called as this angle. Okay, it is also a different name of chi angle. Okay, so we have learnt 4 angles. Everybody is ready? Shall we just make a quick recap of the 4 angles? Shall I ask you true or false? You will reply me. Yes? Be ready with your comment box. C alpha C, I say that it is going to be a boring psi angle. True or false? If true, type T. If false, type F. Come on everybody in the class. C alpha C, it is going to be the chi, or it is going to be the boring angle. True or false? Yes, definitely I am writing it, Selva. Yes? Good net aspirant. Yes, Devika. Very good. Okay. C alpha C, it is going to be the chi angle. Very good everybody. Yes, Selva, it is a chi angle. C alpha N. Okay, so this is going to be, is this omega? True or false? C alpha N is omega. True or false? Yes, Chico, very good evening. C alpha N, it is omega angle. True or false? No, what is the C alpha N? It is going to be, very good. Yes, Devika, net aspirant. Yes, biology. It is a false statement. C alpha N, it is going to be the psi angle. Pi angle. My God, I made a blunder. This is going to be the pi angle. Okay, yes. So this is what is going to be the pi angle. Sorry guys, so kindly note it off. I think I told it as psi, it is pi. Okay, right. Yes, yes. So C alpha and N, it is going to be a interesting angle. So it is called as cute little pi. Okay, right. Cn, it is going to be the omega angle. Got it? Yes. So C and N, it is going to be the omega angle. Yes, yes, that's okay, Selva. So this is going to be the pi angle, cute little pi. This is going, we'll just rewrite it one more time, don't worry. So it tricked you all, right? So we'll write it one more time, don't worry everybody, one more time. Pi, psi, omega and this fellow. So this is going to be C alpha and N. So this is an very boring angle, C alpha C. This is going to be between C and N. This is going to be C alpha and R. Okay. So now all the angles are thorough to everybody in the class. Everybody got clarity in this bond angles. Anybody who is having any doubts on this, please do let me know. Is it all clear? Yes. This is pi. This is this fellow psi. And this is going to be omega. And this is this pi. Got it? Clean? Clear? We'll take an MCQ on this. Yes? Yes or no? Shall we do a question on this? Everybody is ready for a question? Alright, I'll just put a question on this such that you will have a little bit confidence over this topic. Alright. Yes everyone. Okay. Right. Good everyone. So you see here the different angles are given. Okay. So this is a previous gate question. Okay. So let us take this question everyone. Be ready. Okay. Yes Anita. Come on. So they have given W, X, Y and Z. So this is W. So what is W? Can I write it? C alpha and C. Okay. That is going to be W. What is X? X is going to be C alpha and N. And what is Y? It is going to be C N. What is EZ? So EZ is going to be C alpha and R. Right? So that is how the legend shows. This part is first clear to everybody in this class. How they have well classified this one. Yes? Okay. Fantastic. Fantastic everybody in the class. Right. Okay. Great. So now shall we make up a move? Yes? Okay. So now shall we see like what is going to be which one? If you have solved, you can type the answers. Yes, I'll just wait for you all. Yeah, come on guys. Try to solve this. So what should be my P? Yes everyone, try it out. Just now we studied. No? With symbols we know. Yes. Which is boring angle? Which is boring? Got it? See? This is going to be boring angle. Yes? This fellow is only going to be boring angle. This fellow is a cute little pi. So it is interesting. Right? Yes. So Q, it is going to be your 3. Right? Yes? So Q, it should be your 3. Think now. So psi is boring. Psi, it is a boring job, no? So C alpha C, it is going to be psi. Now got it? Yes or no? Cn is very, very rigid. It is omega. So R is 4. This fellow is going to be this guy. Yes? Got it? Everybody in the class, now is this clear to you all? So one more time we will repeat. C alpha C, it is going to be a boring angle. Okay? It is boring. And C alpha and N, it is going to be a very, very happy, cute little pi. Okay? This is pi. Cn, it is rigid omega. C alpha R is going to be this fellow, chi. Now it is clear everyone. So no more confusions in this, I guess. Yes or no? If you have any doubts, please do let me know. Clear? Yes? All of you got clarity now? Yes, Devika, Chiku, Selva. Now it is clear or not? Yes? Okay, fantastic everybody. Yes, all. Absolutely great. Fine, no? So we will make a move. Okay, fine. Now clear? One more time I'll ask you a question. Yes? Okay. C alpha C is psi. True or false? Yes? Come on everyone. C alpha C. Very good. It is a true statement. C alpha N. Yes, A to G biology. It is going to be the pi angle. Very good. It is also a correct statement. C alpha R. This fellow chi. Okay. Right. C N. Omega. True. Okay. So now these are the angles. So among these three, the two are very, very important. One is psi, one is pi. These two are only going to be plotted to make the Ramachandran plot. Okay. So this is going to be a rigid angle. This is not much preferred. So these two are only going to make up our Ramachandran plot. Clear? Right. Fine. So now we will take up one more important thing. How do you think is this peptide bond? Is my peptide bond is planar or it is going to be non-planar? How is my peptide bond? What do you mean by planar? All the angles will lie in one plane. Okay. So if it is non-planar, it is going to move with the side chains. Okay. So Ramachandran plot, it is made up of only main chain, or you consider the side chains. Come on everybody. For Ramachandran plot, it is planar in nature. You consider only the main chain. Okay. So C alpha N, it is going to be the pi. C alpha C, it is the psi. C N, it is going to be the omega. Okay. Clear now? Yes everyone? Yes, it is considering only the main chain. So side chains are not at all taken into consideration. Okay. Right. And it is going to be planar in nature also. Got it? Right. Fine. And if you take up the plot, okay, so Ramachandran, he made the plot for L-alanine residues. He didn't take a big residue and all. He just took a dipeptide. So what did he take? He didn't take a very big peptide and all. He just took a dipeptide. Dipeptide means they will contain only two things, right? So what were they? L-alanine. That's all it will contain. So that is what is called as a dipeptide. Okay. So remember that this Ramachandran plot, it is valid for even the shortest peptides. Okay. Even though your peptides are going to be very, very short, yes, even then it is going to be valid. Understood the logic now? Everybody in the class, is it clear? Like even if it is going to be for the short and the shortest peptide, it is going to work. Okay, right. Yeah, so no, very good evening. Right. Then you are going to make a plot between phi and the psi. Did you find your bond angles everywhere within the plot? Yes. Everywhere the bonds are present? No. So you are having certain regions. Okay. So if it is going to be a white region, it is called as the disallowed region. If it is going to be light blue, little bit dark blue, little bit good, very dark, it is the most acceptable. On what parameter this has been built up? See, if at all I am talking about this point, this is going to be the psi angle. Okay, so this is going to be my pi angle. Maybe my pi angle is going to be minus 90. Okay, my psi angle is going to be plus 120. If at all an atom or my peptide is lying with this angle. Okay, so with my psi angle of 120 and pi angle of minus 90, it is going to have sterically. What do you mean by steric? See, when somebody is coming to your seat, you will not feel comfortable, no? You will just hit them. In buses, in common transport, it happens, no? If you are not getting seats, you will be dashing and sitting. So that is what is called as steric hindrance. So somebody is going to hinder you. That is what is called as steric hindrance. Yeah, Selva. So that is the reason for beta sheet. Okay, so here you are, the steric hindrance is going to be less in this region. That is why it is little bit dark blue in color. In this disallowed region, if I take, see, 0 degree, can any bond exit at 0 degree? It can be 90 degree, 180 degree. Have you ever noted somebody in the 0 degree between two? No, no? Yes? That means that they are at the same location. It will give such a big hindrance. Imagine. True, no? So that is what is the disallowed region. Okay, so it is what it is going to be in the disallowed region. You will not allow your atoms from that region. But these blue color, this all these things, it is going to be the allowed region. Okay, right. So now we are going to learn another important clue called as Ra. Yes. What is this? This is going to be the beta sheet. So beta sheet is going to be in the upper left corner. Okay, right. Yes. So this is going to be the upper left corner. Okay, right. Yes. So this is going to be in this upper left corner and this is going to be in this upper right corner. So this is the lower left corner. This is the lower right corner. So this is applicable for all of my L alanine. Okay, right. Okay, so this is what is going to be the L alanine. Okay, right. So L alanine, this is going to be the thing. So it is going to be your beta sheet, and then in this upper right, it is going to be the left-handed alpha helix. Here it is going to be the right-handed alpha helix. Okay, right. Yes. Okay, fine. So this is Ba, La and Ra. Okay, right. So this is going to be your right-handed alpha helix. So it has both to be negative, and this is your lower right column. It is empty. This is what is applicable for your L amino acid. Okay. So now, if at all a question is coming to you, okay, about your D amino acid, then what will happen? So for your L amino acid, this is going to be Ba, La, Ra. Okay, right. So what will happen? And did you note what is in this x-axis? What is in this x-axis? Was it pi? Anybody noted that? What was in the x-axis? I am saying that it is pi. Correct or not? Come on, everybody. Yes, it was pi. This was psi. Okay, so this is for L amino acid. For the D amino acid, okay, this is going to remain the same, psi and pi. Okay, yes, this is going to be, yeah. So now it is coming opposite. So this becomes Ba. Okay, and this is exchanged. It is Ra, right-handed. This becomes your left-handed. Okay, so there is a swapping. So whatever you see in your left-handed alpha helix, it is getting swapped. It is getting in your D amino acid. For L amino acid, it was Ba, La, Ra. Yes, so this is 0. So this is negative. This is positive. So this is going to be your 0. So this side is going to be positive. Got the point? Yes, everybody. So for B, what are the bond angles? Pi is going to be negative. Psi is going to be positive. Here both my pi and psi are positive. Okay. And here my pi is going to be negative. My psi is also going to be negative. So this is how you are going to mark the angles, even if at all you are not able to recollect the total values. So they will give some values. No, even if at all you are not able to remember all those things, at least this Balara clue you remember, and this x and y axis you remember, very quickly you can plot it. Yes? Will you try this trick here on? Yeah? Okay. So now I will show you one more important table. So this is a very heart of lecture table. So now see this anti-parallel one. Okay. Right. So it is going to be minus and plus. So immediately you have to cross check. Correct? So this is going to be your pi. This is going to be your psi. So this is 0. So this is negative. This is positive. Yes, psi is positive. And how is pi? Pi is negative. Oh my God, correct. So this is how it is going to behave. Like that, you can check and confirm. And one more thing, if it is going to be anti-parallel. Okay, so if it is going to be anti-parallel, right? That means that, so if it is going to be anti-parallel, what does it mean? Both the angles are almost near. Did you note it? Yes. If it is going to be anti-parallel, yeah. So both the angles are almost. It is near 139, 135. If it is going to be parallel, little bit, not much, but still little bit is far away. Okay. If it is alpha helix, both are minus. It is right-handed or left-handed? Quickly tell me. Both are minus. It is right-handed or left-handed? Immediately you will be able to judge it. Am I right or wrong? Come on everybody. Use this Balara clue and tell me what kind of helix is this? Is it right-handed or left-handed? Come on everyone. Think. My pi is also minus. My psi is also minus. So it is coming to this quadrant. This is Ba, this is La, this is Ra. So this is typically for your right-handed alpha helix. Like that, you can come to the conclusion. Okay. So now you got the difference between anti-parallel, parallel beta sheet, right-handed alpha helix, left-handed alpha helix. Okay. Fine. Great. If it is going to be collagen triple helix, it comes under this quadrant. Okay, so like your beta sheet, it is but into 3. Okay, so this is equal in case of your anti-parallel, near in case of parallel, but 3 times in case of the collagen triple helix. So based on these values, you can easily deduct what type of thing is going to take place. Understood? Great? Fantastic. So the next one we are going to see, it is called as beta turn. Okay, so what are these turns? So if you understand what is this turn, it is absolutely going to be of great help. Okay, turns are nothing but they are very short residues numbers. Only 4 residues participate in the turn. Usually this is between your beta sheets. Okay, so see here, whenever there is going to be your beta sheet, just the slides are jumping in a moment. I'll show you how your beta sheet looks like. Okay, so then it will be easy for you to imagine. Alright, so turns, they are very common with your anti-parallel beta sheet. Can you see here? Yes, this is what is called as a turn. Okay, so the turns, they are much the turns are much common with your anti-parallel beta sheet. Okay, because in parallel also it is there, but very prominent these beta turns are present with your anti-parallel one only. And remember, anti-parallel is 7 angstrom long, parallel is only 6.5 angstrom long. Anti-parallel is 7 angstrom long. Why I am telling all this? You will be getting questions that you have to make use of these points. Got it? Okay. So now coming to this beta turns. So beta turns or type 1 and type 2 turns. Okay. So they have the glycine and proline. Glycine will be at the residue number 3, proline at 2. Generally, proline is remarked as a restricted amino acid. What do you mean by restricted? Because it is theoretically it is not that much favorable. Okay, but it is always not bending and not listening properly. But why you want them in the turns? Okay. So have you ever tried with some baskets? So have you ever seen baskets? Yes. So they will be knitting the baskets. So how should be the end? The end, it will be very rigid. Yeah, if the end is not rigid, the total basket will fall off. Okay. Yes. So the turning should be rigid. That is why you keep proline there. Then this part should be little bit flexible. Okay. Right. So this is going to be flexible. Okay. So that is how this glycine is present there. And this is going to be a proline. This is what is type 1, and one more turn is there. It is called as type 2. Right. So majority of the things we have covered: type 1 turn, type 2 turn. Yes. And then we have covered all these things. Now will do some questions. Before that, please note that from June 27th to 30th we have a 20% off going on. So if at all you have not yet subscribed, think of subscription. Use my code Saranya V. Seriously, you like the way of my teaching. Alright, fine. So now, which one of the following statements on protein conformation is not true? Alright, yes, shall we take this question up? Everybody in the class? Okay, come on. Dihedral angles of side chains in amino acid, it is depicted in the Ramachandran plot. True or false? Think. Infrared spectroscopy can be used to deduce hydrogen bonding. Three-dimensional structures of protein composed of 100 amino acids can be obtained by NMR. Globular proteins have alpha helical and beta sheet components. So which is a false statement? Come on everybody, try it out and let me know. Everybody in the class, please try this out and definitely let me know on this. Yes, I told you this point. Side chains do we see in our Ramachandran? Never, no. We never see the side chains. What we saw is only going to be the main chain. Very good everybody. Yes, only the main chain we see. We never see the side chain. Correct, no? So that is why only this option A is going to be incorrect. Okay, so if it is going to be very big, you go with the X-ray. Yeah, if it is very big protein, you go with the X-ray. But if it is going to be the small fellow till 100 residue, you go for NMR. NMR also predicts the angle, no ma. So NMR also has your ABC coordinates. It is going to give you the 3D structure. Okay, so NMR is also very good experiment. Alright, but dihedral angles of only main chain only can be detected. I told you only majorly this pi and this psi. Okay, have you ever heard this chi in our Ramachandran plot? Never, isn't it? Alright, this question is quite big. This one we'll see. Okay, so which is true? The peptides that are unstructured will have all the backbone dihedral angles in the disallowed region. It is not possible to conclude whether a peptide adopts entirely helix or entirely beta sheet conformation. The occurrence of beta turn conformation in a peptide can be deduced. The sequence of the peptide can be deduced, which is true statement. Come on everybody, which is going to be the true statement? Yes. Yeah. Yes, Selva. You can find the beta turn, isn't it? Because I told you a table where the beta turn can be deducted. Correct? It doesn't mean that if it is unstructured, all of them should be somewhere else. If it is a helix or sheet, you can conclude. Sequence, you cannot conclude. So, only available option is option C. Got it? Yes? Okay. Fine. Let me take one more question. Yes. So, this area of allowed region is least for, or you can say that it is restricted for which residue? It is least or restricted for which of the residue? Yes. Allowed region. I told you about the steric hindrance story, no? Who is the notorious fellow? Proline. Okay, right. So, if at all proline is not given in the option, then modified amino acids. Understood? Yes. If proline is there, proline is correct. Proline is not there, then you have to go with the next fellow. Okay, it is the thing. Okay. So, which one of the following statement is incorrect? Yes. Which of the following statement is incorrect? L amino acids can occur in type 1 turns where these two are positive. A peptide rich in proline is unlikely to adopt your alpha helical structure. Proline, they occur in beta. The dihedral angles of your pi and the psi angles of unfolded protein is exclusively positive, which is incorrect. Think. What is your beta thing? They are asking which is incorrect. If it is an unfolded protein, then it should be positive. So think of that also. Which of the options should be right? Yes? How this can possible? No. You cannot say that exclusively if it is positive. It is going to be like this. Never ever you can say. See, proline cannot come in alpha. See, proline is called as helix breaker. It is called as helix breaker. It cannot come. Okay. Alright. And proline is in beta turn. Yes, because it is only going to help in the turn. So both them are positive. It is type 1. That is correct. But if I have my phi and the psi angles, definitely it should be positive only. How I can say that? We cannot conclude like that. No. Yes. That is why it is like that. All right. Fine, guys. And take this question as a homework. Okay. So in the tomorrow's class we will see all the homework question. I think yesterday also I gave you some homework. Yeah. So definitely we will be seeing that tomorrow as well. Okay. So till that, keep learning, keep revising, and seriously all the very best for your preparation. As I said one more time, your examination is very near. Okay. So 60 plus days you have in your hand. Make use of it fruitfully. Definitely you will be cracking the examination. Okay. Right. Okay, thanks a lot everybody. Take care. I'll catch you up in another interesting session. Thanks a lot. All the best.